Okay, so the moons of Saturn. We can't do all of them. There's 82 of them. And actually, we can't even do the most interesting ones. We have to do a subset of the most interesting ones. I've really chosen Titan because Titan is blatantly the most interesting. And then a few others because of these other moons' interactions with the rings of Saturn. Okay? There's every one of the top maybe 10 to 12 to 15 most massive moons of Saturn. They're all totally amusing. Their orbits are weird. Some of them are just the craziest things you can imagine. It's like a circus, okay? What's surrounding Saturn, the rings, the moons, it's like this non-stop, colossal circus all the time. But the king of the circus is certainly Titan. Now, Titan is the second largest moon in the solar system after Ganymede. Okay, so it's big. Second largest after Jupiter's third big moon, Ganymede. Titan is also larger than Mercury. Okay, there are two moons in the solar system larger than Mercury. Those are Titan and Ganymede. The thing to write home about Titan, really there's two things worth mentioning about Titan besides its size. Okay, so the first thing is that it's very large. Okay, it's enormous, bigger than Mercury. The second thing to mention is that it has a very heavy atmosphere. Okay, it's not the only moon to have an atmosphere, but it is by far the most dense and significant of all the atmospheres of all the moons. The atmosphere is, I think, was at 98%, blah, blah, blah. Yeah, 98% nitrogen. Okay, and about 2% CH4, which is methane. Okay, about 2% CH4. So that's the second thing about it. It's very heavy, obvious atmosphere. We cannot see the surface. It's kind of like Venus this way. We can't see the surface of Titan because the atmosphere is so heavy globally, all over it. It's not like the Earth, where we have some clouds some places and some other places don't have clouds. It's like Venus, which is like completely overcast globally all the time. That's what Titan is like. Completely overcast all the time. Nitrogen and methane. The third very amusing thing about Titan is that it's the only other body in the solar system besides the Earth to have standing liquid on its surface. Right? We have water, we have oceans, we have lakes. Standing liquid lakes. Now, it's not water. Water will freeze at the temperatures on the surface of Titan. What composes these lakes is, let's see, methane, liquid methane, which is, like I said, CH4. Ethane, which is C2H6. Is that right? Yes? Yes. And propane. Yes, as in the stuff that we burn here on Earth to make heat and so forth. Propane, which is C3H8. Okay, so these are hydrocarbons. Okay, you wouldn't want to go jumping in these lakes, but they're mostly ethane with majority ethane with significant portions of both methane and propane. So that's what's weird about Titan. Okay, that's what's significant. Those two things. It's very large, has a very heavy atmosphere, and there's standing liquid on it, like significant lakes, like hundreds of square miles of lakes. There's nothing like a global ocean like we have here, but it's like Great Lakes. A really large, significant lakes of hydrocarbons on Titan. The next one I want to mention is Enceladus, which is smaller. And both Titan and Enceladus orbit well outside the rings of Saturn. Okay. So Enceladus, the interesting thing about Enceladus is that it has water geysers, volcanism, water volcanoes really, and also some plate tectonics happening near the South Pole. But what's interesting is these ice geysers. When I say water geysers, I really mean ice. What's being spewed up into the air is really ice. Ice particles, tiny little ice particles, almost like little snowflakes. Okay, that are being projected out into space. And because of this, what happens is this is Saturn here, and here's Saturn's rings. Okay, Enceladus orbits out here, and as it ejects ice from it, the ice makes up an outer ring like this. In other words, there's a trail of ice particles that Enceladus orbits around, and Enceladus itself is responsible for producing these ice particles. The ice particles shoot out of the water geysers, and they do so at higher than the escape velocity, so they escape the gravity of Enceladus altogether, and so it creates a ring outside of well outside of all the other rings, okay, of essentially ice particles. This is known as the E-ring, not for Enceladus. This is just what it was called before it was discovered what the source of the rings is. So Enceladus orbits within its own E-ring. Okay, that's where I told you there were 6 rings, not 5. This is where the 6th ring is. It's out of the orbit of Enceladus. And there's a nice picture of the E-ring figure. So look on page 298. That's figure 1215. I don't know if this is going to show up in the video. Figure, just right at the bottom, 12. Figure what? 1215. I think that'll show up. Yeah, close enough. I'll just say it. Figure 1215. Okay, shows you a nice picture of Enceladus's E-ring. And I want to mention a few other little moons, and these are smaller moons. 2 of them in particular, well, 4 total. I'm going to mention very briefly. Janus and Epimetheus. All right, these are co-orbital moons, which means they occupy almost the same orbit. Okay. As they orbit, so one of the orbits is right outside the other. So let's say that here is Janus, and here's Epimetheus, and Saturn's like down here. There's Saturn. Janus and Epimetheus orbit like this. Now, Epimetheus is in a closer orbit to Saturn, so it's going to go a little bit faster. Every now and again, it's going to overlap Janus, but when it overlaps it, they actually switch positions. They actually do a cross like that. So now Epimetheus is outside of Janus, and Janus is going to eventually lap Epimetheus, and about 4 Earth years later, they're going to switch again. Janus is going to flip back out to the outer orbit, and Epimetheus is going to flip back into the inner orbit. Nice little dance there. Every 4 years, they switch lanes. They're going in the same direction, but they switch lanes. One of them takes the inner lane, the other one takes the outer lane. Okay, about every 4 years. Also, there's Prometheus and Pandora. Okay, Prometheus and Pandora are known as shepherd satellites. Or shepherd moons. They orbit on either side of the F ring. I don't know if you remember the F ring. The F ring was this nice little outer ring just outside, that little thin braided ring I was talking about when I drew the picture over here in the last video. This is the F ring, and the A ring is like down here. Well, Prometheus and Pandora orbit on one of them just inside, and off the top of my head I cannot remember which one's which, but they orbit just outside and just inside of the F ring, and it's their gravity that helps to create the F ring. They're called shepherd satellites because they shepherd all the ice particles into that one lane of the F ring. Okay, and so they are responsible, Prometheus and Pandora are responsible for creating the F ring. And in a similar way, there's a little moon called Pan. It's the innermost moon of Saturn. It orbits in the Inky Gap. Remember that little gap, the outer edge of the A ring, that little narrow gap that was kind of hard to draw in my drawing from my last video? That little Inky Gap is created by the moon Pan. Orbits within the Inky Gap and is responsible for creating it. So there's a lot of dynamic processes going on between the rings and the moons. Okay, they're not independent. Okay, so those are just a few things that you read the whole section on it. There's a lot more moons they mentioned, but these are just a few that I wanted to point out of a special note for you. Just these, I guess, 1, 2, 3, 4, 5, 6, 7 moons out of the 82 that we have to choose from. A lot more could be said, but time prohibits that. See you next time when we talk about Uranus.